Okay, let's discuss how to use Unity and ML agent plus with the PyTorch implement DQN to, to train the intelligent agent to learn how to reach this goal while avoid hitting this obstacle. First, the version we use is Unity 2019.3, and the ML agent we use is 0.14.1. Be careful of the Unity ML agent because it's still in its beta, so the different version may have different settings. So if you want to follow this video, be sure you understand the difference between the ML agent you use and this 0.14.1 because we implement everything under this version. The Unity version I think is okay. So before we start, let's quickly take a look at what's the final result. Okay, so let's take a look at this agent. If we change its behavior type to heuristic, means we use user interaction to control it. So let's play. If you play, okay, you can use W, A, and D to W, A, and D to rotate. Okay, for example, when I go back, I find it's not interacting because every time you remember you have to click the game window again. Okay, so we use W, A, and D for move, rotate, right, and the left. And here in the middle of the middle of the game window, we show the distance of these 5 distance sensors from left to right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. As you can see, the distance detected by the sensor 1 is about 2.5, 2 is longer, and 3. If the ray does not hit anything, we will show 0. Okay, so if I move it back, as you can see, okay, if I move closer, you can see this number is reducing. Okay, and at the bottom, I show the delta x, means the relative distance along the x. So here you can see the relative x is minus because the center of this agent is to the left of the center. Okay, and if I move further, you can see the relative x increase, and the relative y is the y direction. Okay, and here shows the Euclidean distance between the agent and the goal. Okay, so and anytime if you want to visualize your scene from different angle, just go to the scene window and remember use Alt plus your mouse left to rotate. Okay, or you click the, okay, we already talked about this. Okay, the perspective view and orthographic view. Okay, so anytime, but then remember when you want to interact with the game, do remember to click the game window again. Now you can visualize from different angles. Okay, that's the result. Let's close it. Now let's see if we want to use control it in using with Python. Then first we click this and we change the behavior type to default. That means our agent now will be controlled by AI, by a neural network from Python. So when I open the Python, okay, we already run this, so now I connect. Okay, so I go to here, click play. Okay, now I connect and reset my environment and check. Okay, now I interact to collect enough memory, and now I can play. Okay, this is how it looks when it play. Okay, I interrupt it, and then always remember to close. Okay, now if you want to create two words, okay, it's simply just okay, duplicate. Now we have two words. Okay, remember middle mouse, let's select this. Middle mouse to zoom in, zoom out, and to pen. Okay, press your middle mouse to zoom in, zoom out, and pen. If you want to adjust the game window, click the main camera, and there you can adjust the position of your main camera. Select the main camera, select the translation, and then if you want to adjust the size, here I already set the view to orthographic view in order to see it. And if you want to adjust the size, okay, so now we can easily create 2 or 3 or more training environments, and then we go to our Python again. Now let's connect again. Okay, hit play. Okay, reset. And I already collect the data, but anyway I collect it again. Okay, now we start to train. Okay, this is what it will look if we create 2 training environments to train our DQN. Okay, I'm going to interrupt it and do every time to remember to close your environment. Okay, now let's go back. Let's delete this first. Let's work on the one scene first. Okay, roll your middle mouse to zoom in, zoom out, and press your middle mouse to pen. Okay, and to adjust the camera, let's do it again. We move our camera back. Okay, now let's start to take a look at how to build this Unity world. First, we want to build this training world. This training world, okay, contains this one is simply an empty object, so you just create empty and give it a name, for example, world. Okay, and then so this is the empty object. Is underneath, as the children of this training world, it is used to group this object. So plane is this plane, you already know, and the mobile robot is this cube. Okay, and we play 5 distance sensor on top of it. Okay, each of it is again a empty object. For example, let's delete this. Okay, and then I simply create an empty object and move it as the child and just give it a name, sensor. Okay, and I have to move it to zoom in to see whether it is located. For example, I want it located at the middle of my agent. Okay, now I have one, and then I just duplicate. Okay, I have 2, duplicate, I have 3, duplicate, 4, duplicate, 5. Okay, I want to 1, 2, 3, 4, 5. So I'm going to delete this one. Okay, so for sensor 1, I want it, remember, I want it rotate along 60 degrees. So I just change its rotation along y by minus 60. Remember here, be careful your coordinate system is local. If you hit global, okay, and then you change it to minus 60, you will not see it rotate. You will feel strange. Okay, it is because you toggle the global coordinate system. So just click it, change it to local. And for sensor 2, I want it to rotate minus 30 degrees. And sensor 3, the direct. And sensor 4, want it 30 degrees. And then finally sensor 5, 60 degrees. Okay. So now I put 5 sensors on the agent. Okay, in order to detect the distance between the sensor and the goal. Okay. And then the goal is this. Okay. And then the obstacle. Okay. And okay. This is the okay. And then the main camera, we already explained it. Okay. At the direction light. Okay, this canvas is used to display this. Okay, so if I delete it, okay, so if you want to create any user UI elements, go to here. Okay, you see a UI because I want to display text only. Okay, so I just select a text UI, a text UI. And the Unity will automatically place your UI underneath this canvas. So for the first one, I want it to display the sensor data. So I just sensor distance display, for example. Okay, and if you want to change the size, okay, if you want to change the size or the color or the default text display, you just select it. Okay, for example, the default text, I want to display the distance detected by these 5 sensors. Just hit this, then it changes. Okay, if you want to change the size, simply move your mouse here, the font size. You will see the mouse becomes arrow like this, then simply drag. Okay, when your font size become large, you will lose your number because the width is not enough. So let's change our width. Okay, to, for example, 300, then you can still see it. If you want to change the color, click this color. Okay, so click here, then we change its color. Okay, let's create the second GUI text to display the relative distance. So I go to here, UI text. Okay, and just change its name to you just simply click. Okay, and then you can change relative distance display. Okay. Okay, and oh, by the way, sorry, if we want to change the location, oh, okay, let's use this example. Okay, so if we want to change the location of this, okay, let's change the default text first, delta x, delta y, and the final distance. If you want to change the size, simply move your mouse to the font size. Carefully move your mouse here and then move right, left. You can change your size. If the size is too large to be displayed, you need remember change the width, for example, to 300. And also we change our color to red. Okay, now if you want to change its position, remember to press Shift and Alt. Okay, remember to press Shift and Alt together. So now I'm pressing Shift and Alt together, and then select the position. Select here and use your mouse to select the position. One moment. Let's say I want to change. Okay, I select this, Shift Alt and select the, okay. Now see, I change my position. Okay. Maybe I want to change my position here. Let's move our main camera a little bit so I can see this. So let's main camera and move the size. Okay, now we can see. Okay, so now we have already built. Now the next thing is to build our agent. Remember, the first we need add the behavior parameters. We already talked about this. And the space size now is 7 because we want to collect, instead of collect delta x and delta y, we also want to collect the 5 distance detected by the 5 sensors we just installed on the, okay, so the space size now is 7, and the action size is 3 because we perform forward, turn right, and turn left. Okay, and then this model we select none because we will use PyTorch to implement the neural network to control this agent. And then behavior type we change to default if we want to connect to Python. Okay, and the second thing is we need to add agent script. Okay, so here we add the agent script. In this agent script, it's a little bit different from previous one. Okay, first, this ML agent we already explained. First, we need to add one more, okay, namespace called Unity Engine.ui because we are using the GUI text for our game. So we have to include Unity Engine.ui. And then we implement a class. Remember, this class name must be exactly the same as the file. So here, the file name is this, and the class name is the same. And the parent is agent because we want to implement the agent script. Okay, and then the first part is the variable declaration part. And then the functions to initialize agent, the functions to collect observations, the function to perform agent action, and the function to perform agent reset, and the heuristic functions when we are in a heuristic mode. Okay, let us interactively play our game. And finally, we add one more function on collision enter to detect whether the agent collide with the obstacle. Okay, let's take a look at from the variable declaration first. If you see a public, means this variable can be seen in a Unity inspector, and you have to assign it. Okay, so for example, for the first one, we define a public variable called transformed. This data type is transformed, and it's a sensor in here. As you can see, we have a sensor. Similarly, here we define a goal. We have a goal. And similarly, we define a sensor GUI text. Okay, so do remember, anytime you have public variable in your script, you have to manually assign these public variables in Unity. For example, here, okay, we define a public variable called sensor. Okay, its data type is transform, and whenever you see a blanket here, means it's an array. Okay, because we have 5 arrays, so we define an array. So this sensor is a transform array. It contains 5 elements. Similarly, this heat variable is an array. It contains also 5. We will use it to store the distance between the ray and the distance it hit. Okay, so here we have public variables to remember. When you finish, you have to assign. Okay, this is very important. So the sensor, we have 5. Okay, if you see missing transform here, okay, missing. If you forgot to assign this public variable, then when you go to Unity, when you run, connect your Unity, when you run reset, you will see star here. Okay, so whenever you see a star sign here, it cannot be finished. In a environment reset, go check whether you assign your public variable or not. So here I assign sensor 1, sensor 2, sensor 3, sensor 4, and sensor 5. I already assigned a goal and obstacle, and I need to assign these 2 GUI text. Sensor data display, I assign this one, and the relative position display, I assigned it. Now I finish assign the Unity object to my public variables. Okay, now let's take a look at the first initialize agent. We do not do anything, so leave it. Okay, collect observations. Okay, first we calculate the distance x and the z distance and use add vectors. Okay, so we collect these two observations. Okay, delta x and delta z, and then we use a for loop. Okay, because for each of these sensors, we send a ray. Okay, we send a ray from its position along its forward direction. Remember, in Unity, the forward direction is the z. So be sure here, as you can see, RGB, red, green, and blue. So the blue color is z, red color is x, RGB, x, y, z. So be sure all the forward direction is the z direction. Okay, so when you see forward direction in Unity, it means z. And this object heat stores, okay, the distance. Okay, if the ray hit something, the distance will be stored here. If the ray does not hit anything, it will return 0. And the length of this ray, in my program I set it to 9 because I find in my program here I move. See the z from -4 to about 4. So it's about 8. So that's why I want my rate be 9. Be sure I can detect anything within this environment. That's why I set it to 9. And then I add the distance hit by these 5 sensors. So in total, I collect 7 data. That's why in Unity, here I say number of action 7, and also in the mobile agent, in the behavior parameter, I say 7 here. Okay, now the third action defines how the agent should react. So every step we have a minus punishment. We talk about the details of this reward design, so I will not discuss the details of this reward design. And then we have 3 actions. Move forward by 0.2. Remember here we have a word about 8 or 9 meters. Every time we move 0.4, so in total the total steps is about 40 or 50. And we turn right and turn left by 5 degrees. And then we calculate the distance from, because this means the game object, this script is assigned, because this game object is assigned to the agent. So this means this agent. But the distance between the agent and the goal. Okay, remember the goal is a public variable, and we already assign the goal public variable as this goal. Okay, so here we calculate the distance between our agent and our goal. If the distance is less than 1.6, means this. If the distance, okay, between the center of our agent and the goal is less than 1.6, then we add the rework and the simulation is done. Otherwise, we add some minus punishment determined by the distance. We already talked about this reward setting, okay? So you might change this. And then if our agent is out of boundary, this means our agent is local position. We already talked about the local position and the position, okay? So I'm not going to discuss the details. If the local position is less than -4.5, because here I move my agent to about here and check, see, its local position is -4.3. So -4.5 will be something like this, okay? Then, or the x is larger than 4.5, because when I move here, you can see, oh, 4.5. Sorry, 4. And similarly, I move my agent up and down to check the z, value for the boundary. Okay, that's how I determine this value in my program. So in your program, you should modify this based on your environment setting. So if I am out of boundary, I add a -5 punishment, but I do not down. We talk about this. Okay, we just reset the agent. We talk about this to increase the exploration. Okay, and then the agent reset is like I said. Okay, anytime we reset our agent, the position range, okay, randomly assigned from -4 to 4. So the position of x randomly assigned from -4 to 4. And the y keep, because y is this direction, we keep it the same. And the z direction goes from -3.5 to 4. It's the same because the z direction from -3 to 4. I want to move something, okay, in this range. Similarly, I let the obstacle rotate along the y direction from -90 to positive 90. So I let the obstacle rotate. If you move your mouse here, okay, from -90 to +90. Okay. And similarly, I let the goal randomly position in this area, Okay. And then the heuristic, okay, first I calculate the relative distance, x, y, and the distance. And then I display this distance in the relative position display. Remember, the relative position display is this GUI text. Okay, so I will display the relative position here. Similarly, I collect the sensor distance and display in the sensor distance display. Sensor distance display is this. Sensor distance display. Okay, so I display. That's why you see when in a heuristic mode. Okay, in the AI mode we will not display these numbers. Only in a heuristic mode you will see the distance display and the relative distance display. If the relative distance displays, then I just display goal. And then I simply convert W, D, and A to 0, 1, 2, so I to move and rotate left and right. And finally, this on-collision enter just detect whether my agent collides with any object in the environment. Okay, so anything you will collide is be here. In order to do the collision detection, do remember you have to add your agent a rigid body component. Okay, so here, if I remove my rigid body component, for example, and let me see if I change the behavior parameter heuristic, okay, and I play, and then you will see, okay, it will not do collision detection. Okay, so you have to, in order to do collision detection, you have to select the agent and add a rigid body component. Go to add component, go to physics, okay, go and add a rigid body component. Okay, so we add a rigid body component, and then so whenever this agent collides with something, that object will be stored in this variable, and the tag is block. So do remember we need to add a tag to our obstacle. Okay, so to add a tag, okay, so because I already add, if you don't have a tag, you just select add tag, for example, and select, for example, I want add a tag for BBB and hit save. Now we create another tag, and you can select the object, for example, hit BBB or block. Okay, so do remember to add a tag to your obstacle. So if our agent collide with the obstacle, then we add minus reward and then reset. Okay, so we are doing the same thing if the agent is out of the boundary. Okay, if you don't assign the proper obs tag, for example, if I assign BBB, for example, but because our program says if the tag is block, so even so, if you play, remember to click the game window to play. So we can still paint it here. One moment. Oh, sorry, because we already add the rigid body, so we can detect we add the rigid body, so we can detect collision, but we will not reset. See, we will not reset the object. Okay. Now, if we change the tag to block, whenever the agent collides with the obstacle, we will reset. Okay, see, we will reset. Okay, so with this we finish explaining how to design a training environment to train the agent to reach the goal while avoiding the obstacle. For the detailed design, I will explain this in class. Okay.